Today we're doing separable differential equations. This is section 6.3 in your book. And we're going to start off with an example, dy dx equals 2x over y. The way that you know it's a differential equation is because it has a differential in it, right? Okay, and it's an equation. All right, so when we have to solve what's called a separable differential equation, it's called separable because you can separate the x's and the y's. So the first step we need to do is a step called separating the variables, and that's just fancy talk for saying put the x's on one side and put the y's on the other. How do you know which side to do? You always need the dy and the dx to be on top. You have to multiply by them. You should never be dividing by a dy or a dx. So whichever side causes those to be on top is the side that the variable needs to go to. So dy is on top here, which means the y is going to go to the left, and then we would multiply by dx to get the dx over here. Does that make sense? So we're going to separate the variables. So the first thing we're going to do is multiply both sides by y, and multiply both sides by dx. So now we've got separate variables. The x's are on one side, the y's are on the other.
And you call that like separable? What it called? What was it?
Well, this is called separation of variables. This is called a separable differential equation.
That's quite a mouthful.
It is, isn't it?
Can we create an acronym or something? Like SDE?
SDE?
I'll work on it.
Okay. All right. Now, from here, what do you think we're going to have to do next to solve?
Solve for y.
So you want to divide by dy?
I don't want to do that. I don't know what I'm doing.
You can divide both sides by d.
Divide both sides by d.
Right? And then you'd have y squared equals 2x squared, and then take the square root of both sides.
Yeah, that sounds perfect.
Yeah. Does that sound good?
How did you
just get rid of a d?
Close. There you go. All right, we're going to take the integral of both sides.
Oh, just take the integral. Oh, I'm stupid. You can't actually divide by d. Why did I write that? I wrote down like divide by d.
Did you really write divide by d?
And then I just crossed out the d. Why would... Maybe
it's just a joke.
I thought you were making yourself confused.
It was a joke.
Honestly, Miss Price, come on, like, it would have confused me for the rest of the year. Like, I would have been like divided by d, like, I'm so smart.
Oh, I'm sorry. That was a bad one. Oh, your head shakes. All right, so we take the integral of both sides. What is the antiderivative of y with respect to y?
Y squared.
1 over 1 half.
Wow, what is it?
1 half y squared.
1/2 y squared, right? Do not put a plus c. We use 1 plus c to represent all the unknown constants for the equation, and it's much, much easier if you put it with the side that has the x's.
That's nice.
All right? Okay, what's the antiderivative of 2x dx?
X squared.
X squared plus c. Now this is a solution to the differential equation. For this particular problem, that's as far as we're going to go. But from the next problem forward, I'm going to make you solve for y. Because the College Board is going to make you solve for y. By the way, I should also mention that differential equations, being able to solve a differential equation, is probably one of the most important topics on the AP exam. It's one of the few topics that has been in the free response almost every single year since the very first AP exam was ever published. So, and not only that, but it's like free response, you have free response each, there's only 6 questions, 9 points each. Solving a separable differential equation is always worth at least 5, and often 6. So if you're talking about 6 points, and the entire 4-hour exam is only a total of 108 points, right? 6 points is a big deal, especially when there's only about 15 to 20 points separating each score, right? So you have to know how to solve separable differential equations.
15 to 20 points, but...
In between each score, like a 3 and a 4.
Oh, that would make
or
sense.
Or 4 and a 5. Okay.
It's 20 times 5 is like...
Yeah, but it doesn't go like that though. Because 100 is not a 5. Usually 5 is around like a 70.
Oh, really?
Yeah.
So it just starts off like real low.
Starts at like between 15 and 20, somewhere around there. Okay, let's do another example. This one, we're going to take it up a notch. I'm going to make you solve for y, and the solving for y is going to be a little convoluted. We'll streamline it after this example, but I'm going to slow it down and show you a lot of steps just so that you can learn how the math behind what we're doing. All right, everyone ready?
Kinda.
Okay. Everyone take a second and see if you can separate the variables.
And divide out by d. Maybe you shouldn't make that joke from now on. It's kind of scarring me.
Do you know, I actually didn't come up with it.
So you stole somebody else's joke that just will ruin my math career for life.
I did. Someone first period threw it out there and it was awesome. I picked up on it.
Ugh.
Yeah.
Drop a name.
No, I'm not dropping the name. Everyone have the variables separated?
Yes.
Yes. Okay. All right. So what do you have on the left-hand side?
X. Oh, 1 over 1 plus y.
1 over 1 plus y dy equals x dx. You can never add a dx or a dy. You can't have x plus dx. It has to be x times dx. Because this is, remember, height times width. This is an area formula. Height times width. You can't have height plus width. It has to be height times width, right? So it's always times the dy or the dx, never plus. All right. Integrate both sides. Do I have to do a u substitution on the left?
No.
No, because it's just y plus 1, right? Variable plus number, you do not have to do a u sub. But what is the integral of 1 over 1 plus y?
ln.
Absolute value 1 plus y.
Beautiful. ln
I think I have a tumor in my
absolute value 1 plus y.
incredible pain right now.
X squared divided
Do you need to go to the clinic?
No, I'm good. Happens every once in a while.
A random tumor?
Random searing pain in my forehead.
Okay. What's the antiderivative of x?
X squared divided by 2.
Okay, 1/2 x squared plus c.
Ooh.
Now, I'm going to make you solve for y.
Oh, how would you do that?
In order
I don't know how to
to
do
solve for y, this is a logarithmic equation. How would we get rid of that natural logarithm?
Multiply by e.
Yes, that's not multiply by
Raise
e.
it to the e to that power.
Exactly, that's called exponentiate,
Yeah.
right? We're going to exponentiate both sides, which means we're going to make both sides become exponents of e, right? So like we're going to have e to this and e to that.
That's nice.
This is this is where the c, the plus c, it's so crucial that you write it as soon as you take that antiderivative, because if you wait until the end and just add it on, you're going to be really, really wrong. Not like just a little wrong, but super wrong. Because e to the 1/2 x squared plus c, in this case, the plus c is actually a dilation factor. If you did e to the 1/2 x squared and then added a plus c outside of here, it'd be a vertical shift. Totally different. Completely different. So you have to make sure that you put that plus c as soon as you take the antiderivative, and then it's got to be mathematically incorporated along the way.
Does it always have to be with the x, or can you?
It's easier if you keep it with the x. If you put it with the y, you're going to have to just move it over anyway. All right. So now, the reason we do e to the natural log of the absolute value of 1 plus y is because e and natural log are inverse functions, which means they, in essence, kind of cancel each other out, right? So e to the ln of 1 plus y is just the 1 plus y in absolute value. We're closer. Now we need to deal with the c. You're thinking we need to deal with the absolute value. We have to do that too, but we're going to deal with the c first. All right? So to deal with this c, I'm going to rewrite the right-hand side. So the left side I'm just going to keep absolute 1 plus y. And the right-hand side, I'm gonna rewrite this like this. E to the 1/2 x squared times e to the c. I won't always write all these steps. I will skip steps in the future, but for now, I'm just gonna show you how it all works. Do y'all agree that that and that are equivalent?
Yep.
Yes. Because remember, when you're multiplying with exponents, same base, you add the exponents, right? It's just kind of doing that backwards. Hey, e to the c, e is a constant, c is a constant.
It's just a
We have a constant to a constant. This is really just one big constant, right? So, I'm going to rewrite it. Now, I can't use c because c is already represented, so I'm going to use a. The only letter you can't use is k,
Why?
because k is going to have its own significance tomorrow.
I don't think I can replace that A with like smiley face or something. I mean,
You could, but I don't know if I would do that on the AP exam.
replace it with like a detailed drawing of like a cat.
That would be fine too, but I wouldn't if I were you.
I probably
Would
could
they
have
get
my
credit
time.
for that?
Stick with a letter. Just stick with a letter.
They give us credit to use like a picture of a cat.
If you properly and appropriately put it in the correct place every time, I would accept it as a symbolic representation of your constant. Yes.
If I have enough time on like a test in this fast, I'm gonna like do that.
I'm gonna do rocket ship.
Now you would, really off to the side, you should say something like, let, your, whatever your cat is.
I'm gonna bring a stamp in that's gonna have a really detailed picture of a dragon.
Equals e to the c, something like that, right? And then you could put your cat.
Yeah, can we bring in stickers for the test and then just like stick them in where our variables are?
Why don't we just use a letter, like A?
Challenge accepted.
Okay. All right, so now we've got this. So now you can understand why this is a dilation, not a vertical stretch or vertical shift. So anyway, so now I've got absolute value 1 plus y equals a e to the 1/2 x squared. Absolute value. How do we get rid of the absolute value?
Piecewise.
And it's not a piecewise. Merry Christmas. Here's why.
I'm so happy right now.
Okay. Y equals absolute value of x is very different from absolute value of y equals x.
I can see why.
It's like x squared.
Okay? I got that. Okay. Here's the thing. Let me just show you with a number real quick. Say absolute value of y equals 5. Then if absolute value of y is 5, then y would either have to be 5 or -5, right? If absolute value of y equals x, then y has to either be positive x or negative x. So when you have absolute value of y equals something, you can drop the absolute value and replace it with a plus or minus on the other side. So we have 1 plus y equals plus or minus a e to the 1/2 x squared. Here's the part that is going to take a small leap of faith. Okay? The solution to a differential equation has to be a function. It can't just be an expression. It has to be a function. Which means you can't have y equals plus or minus something. Because if you have plus or minus something, that would not be a function. You'd have one input with 2 outputs. So we have to drop the plus or minus. Now what that means is plus or minus a, this whole thing right here has to it just represents one constant. We don't know the constant. It could be a positive number, it could be a negative number. All we know is that it's one constant, it can't be 2 because then it wouldn't be a function. So we're going to drop the plus or minus a, and I'm going to replace it with another letter. I personally like to use m because then I get me.
That's too.
Why me exactly?
Why me? Ah. So what we've done is we've replaced the plus or minus a with just another constant.
I feel like you just really enjoy using different letters in the alphabet.
Sure. Actually, the only reason I picked these is because these are the ones that I've seen done in other texts. So your book doesn't really do a good job of describing how to solve with all of this stuff. A lot of textbooks, when they're doing this, literally just jump from like here to the end.
Oh, that's
And
wonderful.
so it's very hard to understand what the process is. It took a lot of researching different texts to finally find one that would explain it to me carefully so I could understand what was going on. But I found it, and this is what's going on. So there you go. So the last thing that we have to do to solve for y,
Subtract 1.
subtract 1.
Oh my god.
And now you're done.
Bam.
Wait, but then, if you want to plug stuff in now,
Well, if we had to plug something in for x and y and solve for m, you'd be given a point so you could solve for m.
would they give you a value for
No, they would give you an ordered pair that was on the solution, and you'd have to solve for m.
Okay.
Yeah. Which it brings us to our next example, right? Okay.
Mom,
Tomorrow, almost every equation we do will involve natural logs and e. Because if you think about it, tomorrow we're starting exponential growth and decay, right? And the base for all exponential growth and decay, of course, is e,
Do you
right?
have to use substitution on it?
Once in a while you will need u substitution, sure. Sure. All right. All right, find a general solution of 2x plus 3y prime equals 0. Then find the particular solution and I'm going to write y equals f of x. This is how they express that it has to be a function. This is like kind of their way of saying, not only do you have to solve it for y, but you got to solve it for y and your answer had better be a function, right? So find the particular solution, y equals f of x, if the solution passes through the point 1, negative 2. Take a moment, write that down. All right, everyone have it? The very, very, very first thing that you would want to do to find the solution is change something in the original problem.
Y prime to dy dx.
That was beautiful. The first thing you'd want to do is change that y prime to a dy dx, otherwise you can't separate your variables. All right, everyone done writing? Do you need another second? No? Okay. So here's what we have. We have 2x plus 3y dy dx equals 0. We need to get the y's on one side and the x's on the other. Oh, I didn't have the screen so people could see the whole problem. There. How are we going to do that? What should we do?
Subtract the 2x.
Subtract the 2x, right? Because then we've got something where we can multiply and divide, not add and subtract. So there we go. Very last thing we need to do, multiply by dx, right? All right, we have the variables separated. By the way, that's worth a point, right? I might walk you through, show you how these are graded when we're done with this. All right, so we've separated the variables. What do we do next?
Integrate.
Integrate both sides. Shoom. Everyone integrate both sides. Alright, so you should have 3 halves y squared equals negative x squared plus c. Everyone have that?
C.
C? Alright,
You get
this is a perfectly good general solution. They didn't ask for the general solution to be solved for y, so you can, that's fine. But now we've got to find the particular solution, which does have to be solved for y. Personally, I'm going to give you a word of advice. Plug the given point in here. Don't solve for y and then plug in the point. If you solve for y first, what's going to happen is you're going to end up with a y equaling a plus or minus and a square root, and you're going to have a 2/3 c inside the square root, and then you're going to solve for c, and then you're not going to sure if you have to multiply the answer by 2/3 or not, and blah, 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 and it gets all confusing. So plug the point in right here. So we have 3 halves times negative 2 squared equals negative 1 squared plus c. Everyone take a second and solve for c.
Oh,
Already,
she got
yeah.
7.
7, yeah.
Nice job, buddy.
Yeah, a lot of people get 5. The answer is 7.
Because I forgot to stick the negative in front of the one.
Ah, see, everyone gets confused with negative x squared. Negative x squared is not negative x squared, right? This and this are not the same. No one would ever write this because then they just put x squared, right? So that would just be silly. So if you see a negative in front of an x squared, you square first, then multiply by negative 1. Okay, so here's what we have now. We have 3 halves y squared equals negative x squared plus 7. Alright, so we've got c. c is done. Make sure you plug in the c. As soon as you find c, plug it in from wherever you took it from, right? So plug it into there. Now we're going to solve for y. So what should I do first to solve for y?
Multiply 2/3.
Multiply both sides by 2/3. So I get y squared equals negative 2/3 x squared plus 14/3. Okay, what next?
Square root.
Square root. What's the one thing that so many students forget to write with their square roots? Plus or minus. That's really important. Another thing that's really important is students tend to get lazy with the square root symbol, right? So I see a lot of like, the square root is almost like, woo, right? And it only covers a portion of what actually should be inside the square root. If you don't cover the constant, it will be assumed that the constant is not in the square root. And it is. So make sure you don't have any lazy root writing, all right? Make sure that that square root covers everything it needs to cover. No lazy roots. All right, is this a function?
No.
Nope.
No. Y equals plus or minus is not a function. You can have one input with 2 outputs. So we need to pick the plus or the minus. Now you can't just randomly pick. It's not like, hey, pick a sign day, right? We have to actually mathematically choose which is the correct sign. How could we know which sign is the correct one to to go in front.
You're Nick,
Plug in X.
JK, never mind.
You were right.
Yeah, plug in X.
Yeah, if we plug in a 1, the output has to be -2. What is the only way for the point 1, -2 to be on this graph?
If you have negative.
If we have a negative in front. So when you need to know which sign, you use the given point. Use the given point to determine the signs. All right. Now this is a pretty darn easy antiderivative. This would not be a 6-pointer. But here's what I would say, my guess would be how they would apply points. You would get, oops, right here, you get a point for properly separating the variables, right? You would get a point, usually you'll get a point for each antiderivative, but if the antiderivatives are almost identical, if it's a y and an x, so they're both just x squareds or y squareds, then they'll just do 1 for both. But if they're very different functions, they'll give you a point and a point. You get a point for writing plus c on that line. And every AP exam will have the same note. It'll say, if no plus c, max of 2 points for this problem. And they won't even read further. Every AP exam reader said the same thing to me. If there is no plus c on the first line of the solution to the differential equation, they don't even look at anything else in the problem. Nothing else can be right. So, 2 out of 5 for this one if no plus c. You just lost 3 points for that plus c. All right, then of course there's a point for finding c, right? So there's always a point for finding your unknown constant. And then for this one, there would probably be one final point for the solution. So this would, my guess is this would be a 5-pointer. A 6-pointer would be if you had different antiderivatives on each side. That would be a 6-pointer. Very common. 5 or 6 points for separable differential equations just about every single time.
How many separable differential equations?
How what?
How many are there?
1.
Just 1?
Every year in the free response. Yeah, there could be some in the multiple choice, but there's always one big one in the free response, and it always has words associated with it. So we'll start tomorrow with words. Today we're just doing the hows. All right, one more example. Someone, I think it was Noah, asked if you would ever have to face U substitution with a separable differential equation, right?
Yep.
Okay, so let's do one with a little, it's just a little U substitution. So we're going to do ditto for y prime equals 6 cosine pi x.
What is ditto?
Ditto
Just say-
means do the exact same instructions.
Oh,
just
I
new
got
function.
you.
Some people do that for their Christmas decorations.
I thought it was a type of Pokemon.
It is a type of Pokemon.
Oh, okay.
There's a Pokemon named
Yeah, it's
Ditto.
this
It's the
pink
one that can
blob.
copy all the other Pokemon.
It copies everything else.
It's pretty
Ah,
What's called
It's pretty
ditto.
common though. So
okay,
it's not that.
good. Tommy, you doing okay? All right, there we go. Y prime equals 6 cosine pi x passes through the point 1, 2. Everyone see if you can go ahead and first rewrite the original problem the way it needs to be written, and then see if you can separate the variables, and then see if you can go ahead and solve both sides of the integrals. Chandler, how you doing? Good.
Alright, you done that yet? I was writing out the entire word problem. Alright. You know what? I don't need your stats, JP. All I do is be nice to you every single day. And this is the treatment. I am having a rough day. But thanks to Miss Price teaching me the wrong thing, divide by D.
I think it's gonna be
She
fine.
laughed.
This made your day worse, huh?
Yeah, she laughed. She's like, ha 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 ha, he's gonna fail on the test now.
I'm disappointed you didn't enjoy the joke.
Now that I look back on it,
DX.
it was pretty good.
DU.
But I was so happy. I was like, oh, this is gonna be so easy. And then I did it, and I was like, oh, I had to solve it, and you're like, just kidding. And I was like, wow,
Oh,
I can't believe I felt
JK.
that.
I was finished.
Oh, well, crap.
What was the very first thing that you needed to do?
Y prime and dy.
Change y prime to dy dx. Mustafa, are you talking about the problem? Good. Alright, this is a pretty easy one to separate. If you don't separate, you get nothing. Just so you know, if in these problems, anyone who doesn't separate the variables, it's an easy full credit off and I don't even have to read the rest, so it makes grading fun, right? Grading is easy if you do really well or like really, really, really bad, like blank. If you leave it blank, it's easy to grade. If you do really well, it's easy to grade. Anything in between makes it hard.
Sorry.
As you should be.
You should be. Perfect
I'm
grade.
kidding. Alright.
You can't get it perfect, just leave it blank.
No, you should never leave it blank.
Lessons learned by
Never leave it blank, ever.
But we
Never.
want to make your life easier.
No!
Your like little kid was sick the other day. I mean, we just need to be like kind to you.
My little kid went to the nurse's office again today.
Is he alright?
He's fine.
Okay. Did your little kid ever like swallow like a marble?
Not that I'm aware of.
You know what's really dangerous is when little kids swallow magnets.
Yeah, I've
And
heard
if they
that.
swallow like another one, then it like gets connected in their
Right,
like,
it connects
intestines
their
and then like
organs.
rips them up.
Yeah.
That
Yeah.
sounds delicious.
'Cause they're like really small. And
Do you know one way to stop your kid from eating stuff off the floor? That I
Pick it
learned.
up.
Vinegar?
I learned accidentally and ran it by the doctor and they said it was absolutely fine to do.
Pick it up.
I was making a salad and I had jalapeno slices. And one had fallen on the floor. And my little kid, who was like a little crawling vacuum cleaner then, right, crawled over, grabbed it up, put it in his mouth, and you could, his face just, tears, he was so upset with his face of eating that jalapeno. And the doctor's like, really, you could just spread them all over the house. And I'm like, no, I'm not really gonna do that. But every once in a while, if he started getting in the habit again, I would put one in with his other stuff and he would grab, and then he would stop eating off the floor for a while. So
It's going on camera too.
no, I don't know if that's on camera. I'm off the screen,
Oh.
so a little bit.
That was Miss Price telling how she tortured her baby. In case you didn't know.
Is that torture? I eat jalapenos all
It's
the
classical
time.
conditioning.
There's nothing wrong with that.
You're conditioning the way like Pavlov conditioned his dogs.
Yeah.
That's what you're doing.
Here we go. Antiderivative on this side is simple, 1/2 y squared.
Ta-da.
This side requires a little u substitution. What does the u need to be for this problem? Pi x. Whenever your argument's not just x, you need to make it a u. So it can't be the whole cosine because there's no derivative of cosine in this problem, so you get stuck. So it's just the pi x. The du is just pi dx. So we need to do a 1/pi du equals dx. If you want to go ahead and get the 6 dx, go ahead and multiply both sides by 6. 6/pi du equals 6 dx. So now what we have is the integral of 6/pi cosine u du. So we get 1/2 y squared equals, what's the antiderivative of cosine?
Sine,
Is it positive or negative?
positive.
It is positive. 6/pi sine u plus c. So we get 1/2 y squared equals 6 over pi sine pi x
Plug it in.
plus c. Alright, so this would be a 6-pointer, right? Because you get a point for separating, and then a point for each antiderivative, and a point for the plus c. That's 4 points just right up to here, right?
Wow.
Okay, then you get a point for finding c. So we plug in a 1 for x and a 2 for y. Everyone, I want you to do that. I want you to find c.
Just give me like rap. That's like the 2 equals 6.
I know, but it's like so random. Like, what the heck? Is that like so random? Not if I just. I mean, I'm not like so excited. It's like very just surprised. It's like a very random.
No, it's not my choice. Yeah, it's a little surprise. It's just
Switch it up a little bit.
Never mind.
Why do you think it was?
We figured it out.
You know that I.
Okay, this group figured it out.
Oh, see?
You guys got it too? Good. You got it too? Okay. In order to find this, you need to know the sign of pi. What's the sign of pi? 0. So you get 4 squared over 2, which is 2, equals 0 plus c or c. So now we've got the equation 1/2 y squared equals 6 over pi sine pi x plus 2.
Is that a point right there?
That's a point, yes. This is a point right here. So now you're up to 5 points. We need the last point. We've got to solve for y. What do we do first?
Multiply by 2.
Multiply everything by 2. We get y squared equals 12 over pi sine pi x plus 4. Last thing, square root both sides. I got to pick a plus or a minus to go in front of my root symbol.
I'm assuming it's a plus.
It is a plus. How do you know it's a plus?
Because it's positive.
Because if x is 1, y is positive 2, and the only way for y to be a positive 2 is if there's a plus in front. This was one of those few problems where if you were not a good square rooter and didn't normally put the plus or minus, you got away with it.
Hey.
Yeah. Yes?
If you had, what if you had a negative x value? Like would that change, or a negative, yeah, would that change anything? Would you
Well,
have to-
you mean for your original point?
yes,
Well, it might change the value of your c, and
but you still just look at the y value no matter what, like,
well, when you plug in the x, you're going to get that y. It's otherwise you did something wrong, right? But you have to figure out usually what'll happen is you'll get something here where this will be required. It's usually the sign of the y that just forces the sign. But yeah, sometimes you do have to look at both. Okay, does that make sense? Now, tomorrow we start